everybody. Today we are going to learn the new content, factors affecting the solubility. As we all know, the solubility of precipitate is a very important factor for the accuracy of both precipitation titration method and precipitation gravimetry. In fact, there are many factors influencing precipitate solubility, such as salt effect, cold ion effect, acid effect, and complexing effect, etc. The existence of these factors will cause shift of precipitate dissolution equilibrium, thus affect the solubility. Hence, are these factors positively or negatively correlated to changes in precipitate solubility? Now, let's discuss it in detail. First, the salt effect. From the calculation formula of solubility, it can be seen that the solubility is closely related to the solubility product, KSP, in both the ideal state and a situation with the existence of secondary reactions. According to the calculation formula of solubility product, KSP is inversely proportional to the product of the activity coefficients of M and A in the solution. In the presence of salt effect, ionic strength will increase. According to the ionic strength calculation formula and Davis empirical formula, we will find the greater ionic strength, the smaller ion activity coefficient is. Hence, the solubility increases with the increase of KSP. The right picture shows a curve of the solubility of barium sulfate and silver chloride precipitation in potassium nitrate solution with different concentration levels. As can be seen from the figure, the solubility of barium sulfate and silver chloride both increase respectively with the increase of the concentration of potassium nitrate. The solubility of barium sulfate increased more obviously. According to the calculation formula of ionic strength, we know that the higher charge number of crystal ion, the greater ionic strength is, and the smaller its activity coefficient is. So the salt effect becomes more serious. Hence, it can be understood why the growth rate of the solubility of barium sulfate is bigger than that of silver chloride in the diagram. At equilibrium state, if we add a certain reagent containing crystal ion M or A into solution, the precipitation equilibrium will be damaged, and the reaction moves to the left side, thus the decrease of the solubility of precipitate. This phenomenon is called cold ion effect. Clearly, the presence of cold ion effect will reduce the solubility of precipitate. Since the cold ion effect can greatly reduce the solubility, is it better to add more precipitants in each analysis? Let's check this set of data. It describes the change of the lead sulfate solubility in sodium sulfate solutions with different concentrations. The crystalline ion of sodium sulfate is sulfate. The top row is the concentrations of sulfate, and the bottom row is a change about precipitate solubility. As can be seen from the table, with the increase of the concentration of sulfate, the solubility presents a downward trend. However, when the concentration exceeds 0.04 mol per liter, the solubility no longer decreases, but increases substantially. It indicates that the greater concentration of precipitant not always benefits the solubility. The solubility mainly depends on the cold ion effect when added amount of precipitant is relatively small. When the amount of precipitant exceeds a certain value, the salt effect greatly affects the solubility because ionic strength increases as a result of the increasing electrolyte concentration. Therefore, in gravimetric analysis, although the solubility of precipitant can be reduced by using co-ion effect. The amount of precipitant should be carefully controlled. In the precipitation equilibrium, both M and A may react with hydroxide or hydrogen ion in the solution, which is the acid effect. When the system has acid effect, the alpha coefficients are greater than 1. Obviously, the solubility is higher than before, which can also be obtained from the dissociation equilibrium of precipitate. If the acid effect exists in system, which means the hydrolysis of crystal ion M or A occur, the concentration of them is reduced and the equilibrium moves to the right, leading to stronger dissociation of precipitate Ma. In the side reaction effects, besides acid effect, M and A can also combine with other ions in the solution, leading to the increase of solubility, which is called the complexing effect. Taking silver chloride precipitate, for example, when excess of chloride is added into the solution, the chemical equilibrium will move towards the direction of the generation of silver chloride, whose solubility is declining due to the co-ion effect. When the excessive concentration of chloride reaches 10 to the minus 2.4 power mole per liter, that is, the point where P chloride equal to 2.4 in the picture, the solubility of silver chloride is the lowest. As the concentration of chloride further increases, stepwise complexation will occur between chloride and silver, namely complexing effect, which leads to the gradual increase of the solubility. So the precipitate solubility in the figure shows a significant rising trend. Besides the effects of salt effect, co-ion effect, acid effect, and the complexing effect, precipitate solubility is also affected by other factors such as temperature, particle size of precipitate, and a solvent. The higher the temperature, the greater the solubility will be, and the solubility of precipitate with smaller particles will be greater. Therefore, in the process of precipitation gravimetry, the precipitate particles with large size should be obtained as much as possible. On the other hand, most of inorganic precipitates are ion crystals, and their solubility in organic solvent is smaller than in water. Hence, when a precipitation reaction takes place, certain organic solvents will be added to reduce the solubility. At the end of the course, I would like to give you a practice. Please calculate the solubility of calcium oxalate in pure water, solution of pH 1 and pH 4, respectively. Find whether the solubility of calcium oxalate varies under different conditions. That's all for today. Thank you for your attention.